My name is Sushant Sujir Kumar. Today I will be presenting my topical review on the title AI powered localization for mobile robots, an overview of current techniques and prospects. So, I have analyzed five recent research papers published between 2020 to 2025. And over the next 15 minutes, I will show how localization has evolved from classical probabilistic method to modern AI driven optimization. So let's start with introduction. So what is localization? Localization is a foundation of robot autonomy. It allows robots to estimate its current position and orientation, so that the robot can navigate in an environment. Consider robots standing in a closed environment, as for example indoor robot. So to make its movement, that is to navigate to another goal point, the robot has to know its current position and orientation. uh, to know this current orientation and the position of robot, we are using localization and the current approaches. So to find the current position, we are using current approaches like Kalman filter for nonlinear estimation, and Monte Carlo localization, and geometry mapping techniques. So moving forward, why AI driven localization? What is the important of it, and how can it affect from the classical method, and what changes can be done through for the current classical method? So to understand this, we have to know how the localization work. So basically, consider a robot in an environment. So the robot will have the multiple sensors like lidars, IMU, encoder wheels. So the sensor will take the reading from the environment, and all the sensor readings from the multiple sensor will be sent towards the microcontroller, where the controller has a specific program running through, like algorithm, like Kalman filter. The all the readings will be sent to the Kalman filter, where the noise will be washed out, and it will help the robot to know the current position. So when we add two more sensors, like when we increase the number of sensors, the accuracy will also increase. But the problem is, for the classical method, when we increase the sensor, the Kalman filter will have the difficulty to filter out all the noises. So when we implement AI to it, so AI can easily differentiate between the noises, and it can predict from the multiple sensor. It can predict the best approach, best current location and orientation. So it can improve the accuracy and adaptability, and the real world applications like indoor service robot in hospitals, and warehouse robots, like used in warehouse for autonomous package stacking, and uh, all these methods can be improved more for the when we add AI to it. To carry out this topical review, I used a structured Prismascope approach. I selected five peer review research paper from IEEE published between 2020 and 2024, covering classical, hybrid, and AI-based localization approaches. The objectives were to summarize state-of-art localization methods, to analyze their competitive performance, to identify future directions. This paper forms a continuous timeline, like starting from Campbell's 2020 theoretical review to Zhang's 2023 optimized based model, reflecting how the field has matured in just 5 years. Together, they show strong progress, but also reveal that productability and real time testing are still limited in many academic studies. The classical probabilistic method. Campbell, 2020, this paper reviewed key techniques like extended Kalman filter and Monte Carlo localization, highlighting their efficiency and reliability. Like in this paper, they actually uh, they theoretically proven that still extended Kalman filter and Monte Carlo localization gives uh, kind of accurate results, so that for current situation, and still it is a best approach and stable standard approach using these methods. And how the extended Kalman filter works is like, the take the sensor reading from the environment by the sensors, multiple sensors, going to the controller, and from the controller, like for the robot, mobile robot, and all the sensor reading will be uh, given to the Kalman filter, and the Kalman filter will be erasing all the noises as much as it can, and stabilizing and bringing into accurate position, and giving that output into the robot, uh, to the robot, so that it no to the robot, yeah, to the robot, and then the robot will give the output, like it will know where currently it is located. And Hernanda, Rosa, and Faudi, the paper from 2022, they actually implemented the first paper from the 2022 by Campbell. They just done the theoretical approach, but Hernanda and Stream, in 2022, they implemented extended Kalman filter, and actually it is a different approach. I felt it is like really a rare approach, yeah, because they combined with the extended Kalman filter with the PID control. So in the most of the mobile robots are used like using the differential drive, like independent motor for each wheel. So they use uh, forward direction and reverse direction to change its orientation. But the thing is, they implemented in a Ackermann steered robot. So basically, this comes under outdoor robot, which uses GPS and IMU sensor to achieving and using that they actually achieved a good result, like achieved around 1 meter waypoint accuracy. So these two papers just tells us that uh, both the study just tells that still the classical filters are still performing well and stable enough for the environment, performing in the baseline, like it is a standard method, so that even it is worth it to using that method in a low budget way. And however they limit by their assumption, like linear motion and noise cancellation. When we add multiple reading, multiple sensors to make it accurate, still it cannot filter out that some noises, and it is not that accurate enough to uh, perform. So when we add AI to it, so it can be increased its accuracy. Yeah. So moving forward to the visual based localization. Actually, Campbell and their team in the paper 2022, they also discussed about visual SLAM framework. While like first they discussed about sensor fusion like classical method, then they added a camera to it, so that how accuracy can be improved by adding vision. So they all the approaches were done theoretically. So while Ethicals and team from the paper 2024, they fused camera with the IMU and IMU automated data using uncertained Kalman filter for improving the accuracy. So together, this study demonstrate a clear trend towards combining visual approach to the inertial data. Like consider a robot having a eye. So having a high eyes can be seen, and it is easy to predict for the robot to identify its location. And having fused with the combined with the both the approaches, it can improve lot towards like 20% more than the previous approach. So and it creates more stable and systematically aware of the location. Yet both paper also acknowledge the limitations, like adding the vision localization. uh, it is normal, like when we add something extra like vision, whenever it comes to vision, it requires lot of computational power. So when the robot size decreases, it and also the components will also should be resized for the compactness, and due to that, processing a large data, and continuous vision data, it's too difficult and also consumes more energy. So this approach can be done in a large industrial robot. So uh, this is the drawback where they faced. It's not a drawback, it's a limitation. uh, like vision can be used, but in a certain only for the certain application. The third theme is multi-sensor fusion approach. So Yatigul's 2024 paper demonstrated the integration of LiDAR, IMU, and camera data, which significantly improves the localization. But especially Bahrom's work showed that uncertain Kalman filter outperform extended Kalman filter up to 23% when it comes under noise when it comes under noise conditions. And also, both studies point towards unified conclusions. Like also, when it comes to wheel drift, the multiple sensor using the multiple sensor uh, improves 40% of wheel drift reduction, because when we take the reading of encoder, when it comes to wheel drift, the reading cannot be uh, accurate, because when the drift occurs, the encoder will also count the drift counts, so it cannot be used. So they are using multiple sensor so that it can be accurate position reading and orientation reading. However, this improvements comes under cost of computational load and system complexity, which can limit the deployment on smaller and resource constrained robots. So the next major development is optimization based in localization. So Zhang Wang, the paper from 2023, proposed a factor graph fusion model that integrates IMU, LiDAR, and odometry data. By treating localization as a graph optimization problem, their system achieved up to 40% reduction in mean localization error compared to extended Kalman filter. This approach builds directly upon the weaknesses identified in earlier fusion-based systems, offering globally constant position estimation rather than incremental ones. It delivers computational accuracy, but at high computational cost, making it better suitable for high-end autonomous system rather than compact robots. Yeah. And now this slide shows all the papers and the year of publishment and the methods they have used, like adding a sensor fusion, factor graph fusion, and the sensors which they have used, and their key strengths and the limitation of the method. So this progress show how the field is steadily overcoming the previous limitations. Yet practical deployment still requires efficiency improvements to balance power and performance. In conclusion, localization has been evolving fastly throughout the year, like from the classical approach to advanced AI level. Uh, and when it comes to synthesizing the findings across all the five papers, it evident that hybrid model combining the hybrid approaches gives the best outcome and represent the most promising direction for the robotics. Uh, Looking forward in research, must focus on developing lightweight AI algorithm for real time operation, like so that it can reduce the computational power as well as cost effective. Across all five papers, common perform metrics include root mean square errors, trajectory drift, and latency. So Ananda paper 2022 achieved 1 meter accuracy, and Ethical's 2024 paper reduced RMSC by 23%, and Zhang et al. 2023 paper achieved a 40% error reduction. So the trend is clear. As we move from classical to AI and optimized method, accuracy improves. Yeah, accuracy certainly improves, but yeah, it shows constantly across all the studies. However, each gain is in the precision increase the computational power and computational demands. This trade-off remains the central challenge for the future research in real-time localization. In the reference slide, all the research paper has been given in the slide. And the one more interesting topic I want to share is, like, there was a paper by Sampechuda published in 2008. They actually discussed about RFID method of localization. It's a really old method. So From that method, we come to know that from 2008 it started with RFID method, and now it is going towards the AI approach. Knowledge that I have used AI like tools like ChatGPT, Gemini to refine my text and spellings and grammar mistake. So and rest of the contents are entirely my own and based on the study academic resources. And thank you so much.